Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. Please like, share, and subscribe. In this video, I'll be calculating the AC values from the Chapter 15 math handout, problem number 15. All right, here we have a basic combination circuit. So from the Chapter 15 math handout, I have filled in my values given, 18 volts VE, and my 4 resistor values. Since it's a basic combination circuit, my first objective is to find RT. If I look at how the circuit is constructed, I've got R1 and R4, which are in series with the voltage source, and I've got R2 and R3, which are in parallel with the voltage source. So the first thing I'm going to do is I'm going to take R2 and R3, and I'm going to put them through the reciprocal formula because they are in parallel. 1 over under 1 over under 300 ohms plus 1 over under 600 ohms gives me a value of 200 ohms. R1 and R4, I'm just going to bring those straight over as they are for now. So now I have 150 ohms, 200 ohms, and 100 ohms in series. I take these three resistors, since they're in series, and I just add them together, giving me a total resistance of 450 ohms. Now I've got 2 out of 3. I can find IT, 18 volts, divided by 450 ohms, gives me 40 milliamps. 18 over 450 gives me 40 milliamps. All right, I see that in this case, R1 and R4 are on the main branch. So that tells me that I1 and I4 are going to be the same as IT, because the full current must flow through those resistors. And that equation would look something like this. IT is equal to I1, which is equal to I4. All right, now I've got 2 out of 3. I can solve for V1, I1 times R1, giving me 6 volts. I can solve for V4, I4 times R4, giving me 4 volts. V2 and V3 will have the same value because they are in parallel, but it can't be the full 18 volts because we dropped 6 volts at V1, we dropped 4 volts at V4. So 6 plus 4 is 10. I subtract that 10 from the 18, and that gives me 8 volts for both V2 and V3. This equation, V2 equals V3, which equals the VT minus the V1 plus the V4. All right, now I've got 2 out of 3 for I2. I can solve for that. V2 divided by R2. I can solve for I3. V3 divided by R3. Now I just have to find my AC values. So I'm first asked for IT peak. I have an IT of 40 milliamps, which is an IT RMS. So I take the 40 milliamps times 1.414, and this gives me my IT peak of 56.56 milliamps. I had an RMS value here, multiplied it times that to get the peak. V1 peak to peak. All right, so I have a V1 RMS of 6 volts. So I take the 6 times 1.414, gives me 8.48. That would be my V1 peak. If I say times 2, that gives me my V1 peak to peak, 16.97 volts. Next, I need my VT-RMS. Well, these are RMS values already. So the VT of 18 volts is the RMS value. VT-RMS equals 18 volts. Here are the steps that I took to solve the problem. First, I found RT. Then I calculated IT, and I understood that I1 and I4 were on the main branch, so they were all the same value. Once I had I1 and I4, I could find V1 and V4 by multiplying I1 times R1. That gave me V1. I4 times R4 gave me V4. Then I just took the V1 and the V4 value, subtracted them from the VT value, and that gave me the value of both V2 and V3, which were the same because they're in parallel. After I had those values, I was able to solve using Ohm's law, I2 and I3. After these steps were completed, I applied the appropriate formula here to find these values.